Today we're going to learn how to solve quadratic inequalities. So we're going to take a look at graphing a quadratic inequality, which is very similar to graphing a quadratic equation, except that we'll have a parabola that's either a solid or a dotted line, and then we'll have shading on our graph as well. And we're going to take a look at comparing it to linear inequalities. All right, so step one is get your quadratic graphed. And we learned how to do this in, I want to say it was section 5.2b, was when we learned how to put all of the information that we learned about quadratics together in order to get it graphed. Now our first graph is in vertex form, so that makes it a little bit easier to start with. So we're going to identify the vertex, which in this case is 2, 1, because the -2 is in the asylum, so it's the opposite of what we think. There's no stretch or compression because we don't have any multiplication, so this one we can actually use the parent function for the t-chart to graph it. Or we can go ahead and find the y-intercept and then just flip it across the axis of symmetry. So if we want to find the y-intercept, we are going to substitute 0 for x. Now I used an equal sign instead of the inequality because what we are graphing is y equals quantity x minus 2 squared plus 1. The inequality comes in when we look at a solid or a dotted line and then the shading. But the first part is to graph the y equals function. Alright, so evaluating this, we get 2 squared is 4 plus 1 is 5. So there's our y-intercept. And remember the axis of symmetry is the equation x equals the x-coordinate of your vertex, so in this case 2. Alright, so let's plot this information. We've got our vertex at 2, 1. Oh, my calibration is way off. Let me try that again. That's a little better. And then our y-intercept is 5. And then we'll flip that across the axis of symmetry and get a point on the other side as well. And then we can graph our parabola. Now this one is a solid line because we have greater than or equal to. It's a dotted line when it's just greater than or just less than. So I'm trying to get these to hit all my points. All right. And then we figure out where we shade. So what we want to do is test 2 points, one that's inside our parabola and one that's outside, just to make sure that we know where we're shading. We want to shade where the inequality is true. So once we grab those points, obviously 0, 0 is one of the easier points to test, so that's outside my U. And then I will go ahead and just to make sure that it's inside my parabola in case I graph the line's not quite accurate or the curve of the parabola, I'm going to grab the point, let's see, that's 2, 5. So this is the point 2, 5. And then I'm also going to use the point 0, 0. To test and see where my inequality is true. So I'll substitute those back into my function. First I will test 0, 0, substituting 0 in for x and y. Then we ask ourselves, is it true? So in this case we get 4 squared plus 1 is 5. Is 0 greater than or equal to 5? No. So right now it looks like we should shade inside. I just want to double check, so I'm going to substitute 2, 5 into my function. So 5 goes in for x. 2 minus 2 squared is 0, plus 1 is 1. Is 5 greater than or equal to 1? Yes. So we're going to shade inside the parabola.